got y equals x, y equals cube root of x, or x to the 1/3. So I see two kind of pockets here, but it says the region in the first quadrant. So I've got cube root of x and I've got y equals x. Because I have Desmos in front of me, I'm just going to clearly label all of my intersection points. I've got 0, 0, and I've got this point here, which is 1. That's it for part A. Just sketch this region that we're interested in. Part B says write a double integral expression to find the area of R. So, the same form we were just doing a second ago. The only thing, just kind of ignore the surface for right now. Just make the integrand a 1. So I'm going to give you guys a couple seconds to write that double integral expression. We already know, again, that the integrand is going to be a 1. So I'm going from the bottom curve, which is y equals x, up to the top curve, which is cube root of x, or x to the 1/3. And then sweeping in the x direction from x equals 0 to x equals 1.
Now, how can we tell which line to start from? I know we're starting from the integral. How will we know if we're supposed to start from y equals x or?
So you're always going to sweep kind of bottom up.
Bottom up.
So you're going to see me draw this kind of like arbitrary vertical line from this bottom curve, which is y equals x, up to the top curve, which is cube root of x. So B, the only thing we need to remember, if we want the area, just make the integrated 1. So now moving over to C, it says use technology to calculate the volume under the surface. So we're going to like this. You're just going to take the same limits of integration and you're just going to make the integrand the surface itself. So I'm going from 0 to 1, and then from x to cube root of x under e to the xy squared dy dx. Something important to note, you can't use that dA notation here. That's only when you're writing this general region notation, when you're just saying, oh, over the region R. But this question says use technology. So we're going to run over to Desmos. It actually does not matter if you do this in Desmos 2D or 3D, because we're just using a calculator feature, not a graphing feature. So I want the double integral expression from 0 to 1, and then the integral from x to cube root of x, or x to the 1/3, e to the xy squared, And then notice, Desmos said, well, I have no idea what I'm talking about if I do dA. So it is important that we know dy dx. And now, just remember, the innermost integral, like if we accidentally kind of miswrote this, it's kind of confused, because you're saying from x equals x, and it doesn't make sense. You want to go from y equals x to y equals x. So I get 0.305. So calculate the volume under the surface by switching the order of integration. So a question we might have asked a second ago was, well, does it have to be dy then dx? No. So we can do dx then dy. It feels the same. It's not a new formula. The only thing different now is you're not going to be integrating from bottom up. But if you're talking about dx, you're integrating from left to right. So this feels just like Calc 2 when we were doing horizontal integration. So now you're going to see me sketch a horizontal line. And I'm going to integrate from left to right. And then these c to d values are now going to be y values. So I've got e to the x, y squared. I'm swapping the order of integration. So here I had dy, then dx. Here I had dx, then dy. I'm just swapping the order. So now I'm going from left to right, but I need to be careful because the left curve is cube root of x. But if I wrote cube root of x here, you would be writing x equals cube root of x, which is not what we want. So you need to kind of put a star or something to remind yourself that when you're writing in terms of x, your equations have to be written as x equals something. So if I have y equals x, well, and lucky for us, that is just the equation x equals y. Sweet, solved. If you have cube root of x equals y, or rather, if you have y equals cube root of x, if we want to solve for y, then I can cube both sides, and I get x equals y to the third. So again, all I'm saying here is when you're writing, left to right, those equations have to be rewritten as x equals something. So I'm going from x equals y cubed up to the right curve, which is x equals y. And now the outermost integral is dy, so I'm scanning bottom up. So from y equals 0 to y equals 1. You might be looking at the 1 directly above that and going, oh, well the 0 to 1 didn't change. It's actually just a coincidence. It just so happens that both the x's and the y's were the same. Now, I already know, what is the answer to this going to be? It's going to be the previous part. These are the same. You're not all of a sudden going to get a different value. But let's actually verify that we did it right. Run over to Desmos, now type in the other double integral expression. And verify that I indeed did get the same answer. If somewhere, I typed it in, I got different answers, I'm going to go back to my drawing and make sure I did it. Questions?
Question, what if we drop the y from the e to the x y squared? Like, why did
No,
oh, it's not
actually,
supposed to? Okay.
It's supposed to be e to the x.
Okay.
This says let S be the region in the first quadrant bounded by y equals 2x and y equals 6 minus x. Write two double integral expressions that gives the volume underneath that surface over region S. So kind of, the scaffolding. I'm not actually going to ask you to sketch the region by the time we get to the exam. It's more just, you should be able to sketch the region to help you write these integral expressions. So of course, step one, I am going to sketch the region. I've got y equals 2x. Now I've got 6 minus x, that's a positive y-intercept, negative slope. I'm going to cheat, I'm going to use Desmos. I shouldn't say cheat. I'm going to use Desmos to find the intersection points 0, 0, 6, 0, And what is that, 2, 4?
So is it written here? Is it closer?
Say it one more time?
Yeah, same.
Yep. I'm gonna be a little more specific here. I can say and y equals 0. If we were being a little nitpicky, you could say, well, technically this is in the first quadrant too. So I'm gonna say and y equals 0, just so I know we're talking about that. So now, my very first one, I'm gonna integrate with respect to y. And then integrate with respect to x. The problem is, what happens when I investigate my bottom to top idea? Say again?
There's two top.
Yeah, I've got two different functions that are on top. In this part over here, I have to go from y equals 0 to y equals 2x. In this part over here, I have to integrate from y equals 0 to y equals 6 minus x. It's not too bad because I can just take the volume underneath this piece, the volume underneath this piece, and then add them together. So I'm going to do the integral from y equals 0 to y equals 2x, and integrate from what to what in the x direction? 0 to 2, because I want just this piece. Plus from y equals 0 to y equals 6 minus x, from what to what? 2 to 6. 2 to 6. That's one of them. Now, if I asked you to do this by hand, you would just evaluate both integrals using the iterated integral technique, and then adding the two together. And I think for the very first time, you might be seeing why we're not always going to do this bottom to top idea. Because if you were to write this in the other direction, left curve to right curve, your left to right is actually always the same no matter where you sketch it. So maybe the question said something like, write a single double integral that gives the volume. This is not a single double integral. So it's a cue to tell you that you have to find the one that you have to use to be able to write this as one double integral. The only thing here, don't forget, if you're going to write this dx then dy, these equations have to be rewritten in terms of x. I'm going to give you guys a head start. Write those equations in terms of x. And then you want to set it up like this. Left curve to right curve. And then just don't forget the outermost piece, you're sweeping now with the y values, not the x values. So again, the first thing I'm gonna do is just write this in terms of x. Maybe I'm gonna go back over to my sketch and in a different color, say x equals 1/2 y. Don't forget, same thing. If I plotted both of these in Desmos, you're gonna see the same one. You're just writing it as x equals something. Over here, I've got x equals 6 minus y, or negative y plus 6, doesn't matter. So now I'm going from left to right. The left curve, I agree, is y equals 2x. But you're going to refer to this as 1/2 y now. Oh, okay, sorry. All the way up to the right curve, which I agree is 6 minus x. But you're going to refer to that as 6 minus y. And then here, integrating from what to what?
0 to 4.
0 to 4. Don't forget, we're reading the y values now. So you're starting with a y value of 0, going up to a y value of 4. So again, the question says write 2 double integral expressions that give the volume. Both of these are equivalent. If you actually picked a function, plugged it into Desmos, you would get the same decimal approximation for both of these. So again, if it's saying write it as a single integral expression, you have to be able to look at the region and go, well, if I go in the x direction, I have to split it up. But if I integrate in the y direction, then I'll be good to go. Please ask a question. All right, let's go ahead and look at a different, same idea, different problem today. So this one says, consider the double integral expression, and I've got some double integral here. And again, it's very vague as to what the surface is, and that's okay. We're not interested in what the surface is necessarily for today. The question just says, swap the order of integration. Unfortunately, we cannot just make this dy dx and swap some things around. And you might go, well, hang on. You showed us Fubini's theorem last time, which says you can switch the order. But that was if these were all constants, which is not happening here. So I'm going to sketch the region that this is describing in the first place. So why is this a different problem than what we were doing in the past? We had a description of the region, we had to write an integral. We're just kind of going backwards now. Now, you're given the double integral, and you have to be able to draw the region yourself to then switch the order of integration. So this is the equation x equals y squared. This is the equation x equals 4. This is the equation y equals 0. This is the equation y equals 2. So now, x equals y squared. So now, sketch the region, and we might be thinking for a second like, oh, I don't know what x equals y squared looks like. No worries. You just solve for y. You get plus or minus square root of x. And you go, oh, okay, that's a square root of x function, then you got the one below. And if this were Desmos, you would just throw this in there. So I'm gonna give you guys a 45-second head start, sketch the region, and don't forget the goal is to be able to rewrite the double integral expression. So now you're gonna write it dy then dx. How do we feel? So I just sketched everything. I sketched x equals y squared. I don't know what that looks like. Solving for y, oh, okay, it's the positive square root of x and just the reflection, so the negative square root of x. Why did I draw this dashed? Well, it's just kind of peeking at the rest of the regions. I'm going from y equals 0 to y equals 2. I know I want this space here. I actually really don't need this in my drawing at all. Sketch the line y equals 0, the line y equals 2, the line x equals square root of x we have, and then x equals 4. So I remember that if something is written dx then dy, I've got a horizontal line drawn. Well, if I want to treat this by switching the order of integration, I want to do bottom to top. So I need dy then dx. I'm integrating from, careful, y equals 0 to, what am I going to refer to this as? Square root of x. Yep. If it were down here, that would be negative square root of x.
Are we considering the bottom?
Second?
Are we considering the negative part?
Oh, we're not. Now, technically, y equals x squared is this entire parabola.
Why? Are we just ignoring it now, or?
Or you see, why aren't we?
Yeah, why?
Because I'm bounded between y equals 0 and y equals 2.
Oh.
So that's what fixes me. And now I'm sweeping left to right, which is from x equals 0 to x equals 4. So that's the other way you could be presented with this problem is you're given a double integral. You have to sketch the region to get a good idea of what's happening to then rewrite. This says rewrite the order of integration. So you might notice that we actually have an integrand now. We have the z equals x to the third e to the y to the third. This actually has no meaning. Whether you just refer to it as some function or have something written, when you're just swapping the order of integration, you can kind of just ignore it. So this is saying y equals x squared, y equals 9, x equals 0, x equals 3. Sketch. So now, the original one is written dy dx. So this means the original one is going from bottom to top. So if I'm switching the order of integration, I want to go from left curve to right curve.
Y also equal 9.
Say,
Wouldn't Y equal 9?
y, oh yeah. So I want to go dx, then dy. From left curve to right curve. The left curve is y equals x squared. I agree. Did I make a mistake?
The x squared to 9, like when we bottom to top, so would it be inside the row?
Yeah, would it be inside or not?
Yeah.
What
so
from?
Huge. Left would be x equals 0 to x squared.
So we're going bottom to top. So x squared needs to be the bottom curve. All the way up to y equals 9, that needs to be the top piece. So going left to right, I'm starting from x equals 0 to, I agree that is y equals x squared, but you have to write that in terms of x. So you do get plus or minus square root of y, but we're only interested in the positive version. So I'm going from left curve, x equals 0, to right curve, square root of y. And now dy, I'm going from what to what in my y values?
0 to 9.
0 to 9. We want to know we did it right. We can just type both of these into Desmos. Just make sure that we get the same answer for both of them. I made a mistake here and shaded the wrong region. But if we went to go check it, we would have seen two different numbers and went, oh, okay, I know I need to go back and look at this. I like this lesson. You guys like this one, right?
Yeah, this is
Fun.
In the event, like, let's say that it was
Shade.
like what you shaded in originally, what would that look like?
What would the integral look like?
Yeah.
So if it was that one, that would be from square root of y to 3. And then scanning from y values would be 0. So now, we might have noticed that the integrand actually has no meaning here. So to just kind of illustrate why switching the order would exist in the first place, if I wanted to take the antiderivative of this, so antiderivative with respect to y, that's just a constant. I can't do the antiderivative of e to the y to the third. You would need a power series, and even then you can't write it as a closed form. So there is no antiderivative of e to the y to the third. However, if I were to switch the order of integration here, now if I take the antiderivative with respect to x, oh, you just add 1 to the power, divide by the new power. And eventually when you substitute things in, you'll be able to use a technique like u sub or something along the way. So things that you could see, like on the multiple choice section, it might ask you to evaluate an integral. And since we don't have Desmos where we can just type it in, we would have to do this quote unquote by hand. But it might happen where I can't do this integral. So I'm forced to rewrite it. Now I can. Let's go.
excuse me, real quick. The EY to the third, there, you can't, so you can only integrate E raised to the X to the third and not Y to the third, E?
So I can integrate x to the third.
Right.
If this was e to the x to the third, I would not be able to do that. So here, I know that this is x equals, so this is left curve to right curve. So square y, oh, okay, that's the x to the third curve. Up to x equals 2, so it is talking about this region here. So I'm swapping the order of integration, so I want dy, then dx. So I want bottom curve to top curve, so that is from y equals 0 to what? Yep, x to the third. I agree, that is the cube root of y, but you have to refer to it as y equals something. So y equals x to the third. And then dx, sweeping left to right, goes from 0 to. Just giving you kind of a sneak peek into, again, what would happen for this problem. Here, if you want the antiderivative with respect to x, I can't take the antiderivative with respect to x of this thing. Swapping the order of integration with respect to y, oh, well, if this is just a constant, then I've got y times this constant. And when you plug in x to the third, you end up with an x to the third times this piece. You land on a u sum. Truth be told though, maybe I'll ask you to do this like once or twice in a project. When it comes to, an actual test question, it would be more switch the order of integration, done. Rewrite the order, done. I'm not gonna ask you to do the order and then do the integrated integral, unless it was a calculator problem. I would say, part A, rewrite it. B, use technology to write it. All right, I do have lots of practice problems for this one coming around.
Do you know what time the test is gonna be on Thursday?
So Thursday, would 12:30 work?
Yeah.
And then, so Thursday, if you guys are doing the retake, it would just be come to my office next door. So don't come here, come to my office. Bye, everyone. I'll see you Wednesday. Don't forget, we do not have class this Friday.
Oh, the class Friday? Yay!
Yeah.